Have you ever wondered how those really critical services, like your company's main database or file server, somehow stay online, even when a server completely dies? Well, a lot of that magic is powered by a technology called Windows Server Failover Clustering. It's really the secret sauce for what we call high availability, and it's what keeps our digital world from falling apart. So let's dive in and see how this thing actually works.
Okay, but before we jump into the cool solution, we have to talk about the problem. And in the world of IT, there's one word that gives everyone nightmares: downtime. Right? It's the ghost in the machine, and honestly, it's the whole reason technologies like clustering even exist in the first place.
No, really, think about it for a minute. That database that just went offline, it's not just a database, it's the thing that processes every single customer order. That file share that's suddenly unavailable, that's where your entire company collaborates on projects. So when it all goes dark, what's the real damage?
Well, the impact is it's huge. We're talking about lost productivity, for sure. Lost revenue, absolutely. But maybe the worst part is losing the trust of your customers. See, in today's world where everything has to be always on, a service disruption isn't just some technical hiccup anymore. It's a full-blown business failure. And that is exactly why we need a bulletproof solution. So how do we stop that from happening? Well, this brings us to the hero of our story today: failover clustering. Let's break down what this actually is and how it creates that all-important safety net.
So what in the world is a failover cluster? The easiest way to think about it is like a team of servers. We call these individual servers nodes. All these nodes are connected, and they're constantly talking to each other. Their one and only job is to work together as a single unit to make sure your apps and services stay up and running no matter what happens to one of them.
I absolutely love this way of thinking about it. The failover process is basically a relay race for your services. You've got server A, and it's running its leg of the race, carrying that critical service like a baton. But then, whoops, it trips and falls, the server fails. But here's the cool part: it doesn't drop the baton. The cluster, acting like the team captain, sees the fall and instantly, and I mean instantly, hands that baton over to server B, who is just waiting to take over. And for your users, the handoff is so seamless they probably didn't even notice the runner changed. The race just keeps going.
So the benefits here are pretty obvious. First, you get this huge boost in availability for your most important stuff. But it's also proactive. The cluster is always monitoring everything. If a service starts acting wonky, it can automatically restart it or just move it to a healthier node. All of this means your users see little to no disruption. And the secret ingredient that makes this possible is a feature called Cluster Shared Volumes, or CSV. It's kind of like a magic shared hard drive that all the nodes can see and use at the exact same time.
All right, so you're thinking, this sounds great. I want one. What do you actually need to build it? Let's get into the hardware and see what this looks like in the real world.
You can really boil the hardware down to three main pillars. First, you've got the servers themselves, the nodes. Now, ideally, you want these to be identical twins, or at least very close siblings with super similar components. Second, redundant networks. You can't just have one connection between them. You need multiple, separate paths so if one network goes down, they can still talk to each other. And third, pillar number 3, is shared storage. All the nodes have to be able to get to the same data, and that's usually handled by something called a storage area network, or SAN for short.
Now, if we dig a little deeper into that shared storage pillar, there are some really specific rules you got to follow. As you can see here, you have to use basic disks. Dynamic disks just aren't supported. The file system has to be NTFS, which is a hard requirement for those cluster shared volumes we just talked about. And finally, you have to fence off your storage using something called LUN masking. Just think of it like putting up a digital velvet rope that only lets the servers in your cluster access that shared data. It keeps everybody else out.
Okay, so we know what hardware we need. Let's talk about the final phase: actually building the thing, and, maybe even more importantly, how you take care of it and keep it healthy long-term. Putting it all together follows a pretty clear 4-step path. First, you verify all your prerequisites. Make sure your servers are all on the same page. Simple enough. Second, you go and install the failover clustering feature on every single node. But Step 3 is the big one: validate. Windows has this amazing built-in tool that's like a pre-flight checklist for your entire setup. It tests everything, and you absolutely, positively should not move on to the final step, creating the cluster, until that tool gives you a big green checkmark. But hey, building it is just the beginning, right? How do you take care of it? Well, Windows Server actually includes a built-in health service that's like a 24/7 guardian for your cluster. As the documentation puts it, it's constantly on the lookout, monitoring for problems and generating what it calls faults. And the best part about these faults is that they're not some cryptic error code that you have to spend 3 hours Googling. Nope. They are designed from the ground up to be crystal clear. They tell you exactly what's wrong, why you should care, and what you need to do to fix it. The whole goal is to make troubleshooting as painless as possible.
And here is a perfect example of what I'm talking about. Instead of some vague error, look at this. It tells you the severity is minor. The reason? Connectivity has been lost to the physical disk. The recommendation? Check that the physical disk is working and properly connected. I mean, come on. But look at this last part. This is amazing. It can even tell you the physical location, down to the rack, the node, and the exact slot. This turns a frantic, stressful troubleshooting session into a simple, straightforward repair job.
So you've done it. You followed the steps, you built this robust cluster, and now your services are highly available. They're protected from a single server failing. But here's a final thought to leave you with. What happens if your entire data center goes offline because of a fire or a flood? High availability is one thing, but disaster recovery is a whole other level. And that, well, that's a story for another day.